Blue Saints, it's your brother Remain True, around Yahweh. So, right now I'm going to read some of my genetic results from my ancestry report, 23andMe. I'm going to read from the maternal haplogroup, dealing with my mother's side. Okay. You descend from a long line of women that can be traced back to Eastern Africa over 150,000 years ago. These are the women of your maternal line, and your maternal haplogroup sheds light on their story. Your maternal haplogroup is L2a1. As our ancestors ventured out of Eastern Africa, they branched off in diverse groups that crossed and recrossed the globe over tens of thousands of years. Some of their migrations can be traced through haplogroups, families of lineages that descend from a common ancestor. So keep that in mind, man. A haplogroup is a line of people who descend from a common ancestor, okay? Your maternal haplogroup can reveal the path followed by the women of your maternal line. Migrations of your maternal line. Haplogroup L. Now you see that they saying haplogroup L is traced to or is believed to originated at least 180,000 years ago. Okay. If every person living today could trace his or her maternal line back over thousands of generations, all of our lines would meet at a single woman who lived in Eastern Africa between 150,000 and 200,000 years ago. Clearly putting this haplogroup with Mother Eve, okay? Mother Sarah, all right? So on and so forth. Though she was one of perhaps thousands of women alive at the time, only the diverse branches of her haplogroup have survived today. The story of your maternal line begins with her. So, in other words, they're saying you might have a different haplogroup, but the story of your maternal haplogroup, okay, would have to be traced to this woman right here in order for you to be a modern human, all right? Because if you're not out of this haplogroup, then that means that your maternal lineage doesn't go back to this one particular woman, all right, who is the mother of all of the so-called continent of Africa, where she originated and spread throughout all the rest of the world, all right? Your maternal line stems from a branch of haplogroup L2 called L2a1. L2a1 is a widespread branch that arose approximately 24,000 years ago. At the peak of the last ice age, 20,000 years ago, the Sahara Desert became entirely uninhabitable and began expanding to the south. People in Central Africa bearing L2a1 began journeying in two directions: east toward the cooler climate of the eastern highlands and west towards the Atlantic coast. Then beginning about 4,000 years ago, so you see they're getting closer and closer to a common ancestor with this L haplogroup. All right, so now you as recent as 4,000 years ago. They saying so as recent as 4,000 years ago, two sub branches of L2a1, which is L2a1a and L2a1b, were swept up with the Bantu-speaking people of West Africa. Okay? L2a1 and L2a B. Those are two maternal haplogroup branches, okay, that were swept up with the Bantu speaking people of West Africa. So in other words, what they're telling you is that if you understand and know the history of the Bantu people, they are the Hebrew people who were scattered across the earth, okay? And so these two branches right here, all right, descend directly from the first woman, okay, which means that that woman was Eve, all right, and you know, it's my belief, you know, that these all these these descending L branches are from Eve, Sarah, okay, and Rebecca. You see what I'm saying? Straight up, I believe that's Sarah and Rebecca, man. That's Abraham's wife and his son's Isaac's wife. All right, their children. So in other words, these women that represent these two haplogroups right here, these two branches of that L haplogroup, are the children of Sarah and Rebecca. That's my belief. These people who had been practicing farming, now this is where they come in with a bunch of injection just to try to, you know, explain how the migration occurred, other than directly saying it was because of the people being scattered out of East Africa, Northeast Africa, Jerusalem. Okay, they don't want to say that. All right, but that's the reason why these two branches did that so-called Bantu migration. The Bantu migration was a scattering of the Hebrew people because of persecution by the Romans, the Greeks, the Turks, and even the Ishmaelites and the Edomites. All right, all those nations that converged on our land in Israel and scattered us and took the place over, and their DNA is found mostly in our land today. We're gonna get into more of it, okay? Especially dealing with the other female haplogroups that are so-called Jewish. All right, L2a1 is also quite common among the descendants of Africans in North and South America. You see that? So in other words, my haplogroup is common amongst the black people in America. Its high frequency is probably, you see that? You see this BS? Its high frequency is probably due to the concentration of L2a1 in what? In West African, which was the main supply region for the Atlantic slave trade. All right, you see that? These faggots got the nerve to use the word probably due to. Now, how in the hell else did L2a1 come to America? Get the hell out of here, you damn lying-ass Ashkenazis who own this company. And that's the reason why, you know, so many Hebrews are reluctant to get their testing done, because they know they can't trust the damn heathen. However, you just got to take the information that these heathen, okay, have provided and decipher it yourself. You know, in other words, chew the meat, spit out the bone, throw that garbage away that they inject, okay? Such as probably L2a1 being in America because of the Atlantic slave trade. Probably, yeah, okay. All right, now here go another fucking lie. Today, you share your haplogroup with all the maternal line descendants of the common ancestor of L2a1, including other 23andMe customers. All right? But it says that I share that with 1 in 270 customers. So exactly how many freaking customers is that? Because if they only got 270 customers, then that mean I would be the only one. And if you double that number, okay, that 270 number, you get 540, which would mean that 2 out of 540 of their customers have this. So it really depends on how many of their customers got. It really depends. To know the truth of that figure is really to know the truth of how many freaking customers they have. Okay. The Bantu expansion transformed the cultural and genetic landscape of Africa. All right. So you see that they show you that the Bantu expansion started in East Africa, man. All right, here we go. About 5,000 years ago, many people in sub-Saharan Africa still relied on hunting, gathering, and foraging as their main means of collecting food. But that was soon going to change. People in West Central Africa began experimenting with agriculture. So the truth of that is that Jacob was a farmer, a herder, okay, and our people dealt with livestock farms and things, and yeah, farming. All right, our people dealt with that. Okay, Jacob was a master uh, uh, herder and breeder of sheep. Okay. Cultivating the yams, legumes, peppers, and gourds that would become staples of the sub-Saharan African diet. These people spoke languages belonging to the Bantu language family, and about 4,000 years ago they began to move. First, they headed east across the central rainforest. Eventually, the descendants of these migrants arrived at the farthest reaches of southern Africa. Later on, Bantu speakers who had remained in West Africa also began to travel down the western coast. As they traveled over a period of centuries, they both displaced and absorbed many other hunter-gatherer groups that were already living throughout Africa. Their agricultural and technological knowledge also diffused to other local groups. They often intermarried, sometimes adopting local cultural practices of those people they encountered. The languages that they brought with them from their ancestral homeland spread throughout sub-Saharan Africa. You see that the languages that they brought with them from their ancestral homeland, which is Israel, spread throughout sub-Saharan Africa. That's why the Bantu, so-called Bantu speaking Haplo group is all over sub-Saharan Africa. Okay, and you know the well, let's look on. The languages that they brought with them from their ancestral homeland spread throughout sub-Saharan Africa, and today the majority of sub-Saharan African languages are Bantu. Man, okay, the Hamites that were in Africa, they didn't adopt our language, all right? They still speak in non-Bantu languages, okay? All right, so it's not like they adopted our language. No, it's just that all those people who are of Bantu languages are still the same people who were scattered and migrated, okay, across sub-Saharan Africa. And their DNA show that they're all related, okay? You're not going to find Bantu-speaking people who don't have the same haplogroup. So what I'm saying is that it's not like they went and changed the language of Africa. What I'm saying is that they went to Africa, all right, brought their language, and their language distinguishes them from other Africans before DNA exploded. And now that DNA has surfaced to show more facts about ancestry, DNA proves that the Bantu-speaking people are all related, which means that they're all from the same seed and the same common ancestors, all right, which is the Hebrews, according to the scripture and according to prophecy, the way it should be, okay? All right, so that's just, some info on how mitochondrial DNA works. All right, so that was my maternal. That was the report on my maternal side. All right, L2a1. I think that might be good for right now. Then next video, we're gonna look at my paternal side, which the genes from your paternal side are passed directly to you from your father. All right, and the genes from your mother, that what we just looked at, that's passed directly unto you from mother to son and mother to daughter. The X chromosome, all this stuff is based on my X and mitochondrial DNA, X chromosome and mitochondrial DNA that shows you where my mother and her mother and her mother and her mother and her mother come from. The first woman, all right? That's when, and these heathens admit that I descend from the very first woman. All right, they try to say that it was many women alive, but my mother is the only one whose genes survived. Okay, whatever. Whether that's true or not, the bottom line is that the reason why my mother's genes survived is because that's the way the Most High would have it, because He made a promise to my mother, who was Eve, okay, and who was Sarah, and who was Rebecca. All right, yes, straight up. Okay, all right. Uh, I guess, I mean, okay, whatever. Let's just go ahead and read this last little paragraph on the mitochondrial DNA. I guess it wouldn't hurt, right? Uh, maybe somebody could still be edified and informed on something that they didn't know. All right, so let's take a look at this. Maternal haplogroups are determined by sets of genetic variants in a tiny, unusual loop of DNA called mitochondrial DNA. So your maternal haplogroup is determined by your mitochondrial DNA. And that's what they were first using before they got autosomal DNA to show mother and father, and also the other 22 chromosome pairs. All right, all they were using was the mitochondrial, and telling people they're from this tribe and that tribe. Well, that's true. They can show you that your mother is from this place, but it's important to know where your father is from also. Okay. As the name suggests, mtDNA is found in the mitochondria, small but mighty structures inside our cells that turn fuel from the food we eat into energy. Amen. That's right. Mitochondria evolved over billions of years from an independent bacterial cell that was engulfed by another cell. Instead of becoming lunch, the bacterium helped its new host use oxygen to produce energy. Over time, it completely lost its independence and became an integrated part of the larger cell. However, your mitochondria still contains a small separate piece of genetic code, your mtDNA. Okay? Alright. Now let's look at this graph real quick. Let me show it to you. I don't know. All right, maternal inheritance. Only mothers pass their mtDNA down to their children. That's what they say right now. That may or may not be true. That only the mother passes mitochondrial down to the children. But I don't know. I feel like, well, if you're a female and you got two X chromosomes, one from mom and one from dad, I'm like wondering, like, I mean, why doesn't dad give you some of his mitochondrial too? Like, I mean, he gave the girl his X chromosome. He got his X chromosome from his mom. I would think that he would pass some of that down to his daughter. But that's just my opinion. But they say only mothers pass their mtDNA down to their children. All right. So let's look at this graph. All right, as you see, you got two sets of grandparents right there, okay? All right, now if you look at the yellow bar right there, that circle represents the son and the daughter, okay? So it shows you that you see the father is in the reddish or and that purplish color right there. All right, so that's your paternal grandmother. All right, and on the right in the yellow is your maternal grandmother. Okay, so as you see, the way they said they got it broke down, the father side you don't get nothing from his mother, but it says that on your mother's side you get something from her mother, and they say that that is passed down to the daughters and the sons. They're saying only your mother passed mtDNA down to you. Okay. Researchers are able to trace the history of maternal haplogroups back in time because of the unusual way mtDNA is inherited. Each generation passes, each generation, mothers pass essentially identical copies of their mtDNA down to their children. Both males and females inherit mitochondrial DNA from their mothers, but only females pass it on. Okay. However, mtDNA isn't copied perfectly every time. Every so often, a mutation, a change in the DNA sequence, occurs and it passes on to the following generations. Over many generations, mtDNA mutations stack up in patterns that uniquely mark individual maternal lines. And that's their way of justifying if they don't have L as a maternal haplogroup, then their haplogroup that isn't L is just a mutated haplogroup, and now it's changed to a different haplogroup because of mutations. Oh, that's true. Yeah, it may be a mutation, but any mutation that doesn't, bring you back to Africa is a mutation that's more than likely one that lacks melanin, something that else you get from your mama. All right, so if your mutation has taken away your melanin, then you're cursed. Okay, straight up, your ass is you didn't survive. Okay, just like they said, my mother's genes survived. Okay, all right, it wasn't no mutations causing my mother's genes to change and to become different. There were no mutations in my maternal ancestry that caused us to be disconnected from the mother of the earth, which was Eve. See what I'm saying? So in other words, I don't have no mutations. Being in the L haplogroup, I don't have any maternal mutations, okay, that would suggest that I'm any different on my mother's side than the very first modern human woman, which was the woman God created out of Adam's side, which woman was Eve, okay? All right. All right, let's listen to some more of this shit that they gonna try to use to explain why you other women out there may have a different haplogroup due to mutations. Geneticists geneticists can compare the different patterns of mutations in mtDNA sequences from around the world by constructing a tree that shows how all maternal lines are related to one another. Each maternal haplogroup describes individual branches or closely related groups of branches on this tree. See? Individual branches or closely related groups of branches on this tree. Because closely related haplogroups tend to share geographic roots, researchers can use the modern distributions of haplogroups around the world to try to determine where each haplogroup arose and how and when its members reach their current locations. All right? Yeah, that's right. They're trying to explain how they're closely related, but not directly related. Okay? And they're still trying to figure that out. Okay? And, they know. What they know is that those other branches and groups come from Neanderthal ancestry, okay, which they have the skeletal remains of the Neanderthals to test their DNA, and when they test those that aren't of this L haplogroup, that's who they go back to, closely related, but not directly related to this haplogroup, okay? And they say that the Neanderthal is closely related, but not directly related to the modern human, all right? So I hope if you didn't know something that I just said, you learned something, you know, and it sheds some light for you, okay? But that's what it is. My maternal haplogroup uh, is related to the Bantu-speaking people of East Africa, where they claim all the women in the world descend from that woman out of East Africa. All right, let's just go back and show it and reiterate that. You descend from a long line of women that can be traced back to Eastern Africa over 150,000 years ago. These are the women of your maternal line, and your maternal haplogroup sheds light on their story. Your maternal haplogroup is L2, or otherwise known as L2a1. All right? As our ancestors see, they want to put themselves in the mix. As our ancestors ventured out of Eastern Africa, all right, you see that? Eastern Africa. So if the woman started in Eastern Africa, then that means the man started in Eastern Africa. So what haplogroup is there out there that you people admit started in Eastern Africa dealing with the men on the paternal side? Yes, tell us that. What man originated in Eastern Africa? Because at first they wasn't admitting that Bantu-speaking men, okay, E1B1A men, they wasn't admit that they started in Eastern Africa. All right, but so much information has been coming out that it's hard for them to deny that fact now, okay? All right, let's listen to one more last slide. Now look at the graph. All right, that's L, and they showing how L2 is the descendant of L, and L2 is highly concentrated up there in West Africa right now, okay? And what they're saying, okay, so man, we're gonna get into that later when we dig into this so-called Jewish ancestry. But listen to what they admit. If every person living today could trace his or her maternal line back over thousands of generations, all of our lines would meet at a single woman who lived in Eastern Africa between 150,000 and 200,000 years ago. Okay, though she was one of perhaps thousands of women alive at the time, only the diverse branches of her haplogroup have survived to today. The story of your maternal line begins with her. So is all these other I want to see if all you other haplogroups outside of L, okay, I want to see how that connects to this haplogroup. All right, and we're going to do some research on that, and we're going to see if haplogroup, say, L on the maternal side, haplogroup O or something like that. We're going to see if that links back to that woman, all right? But that's the truth about my mother's side, and that's the truth about all humans, okay? That they came from a woman who originated in East Africa. All right? The cradle of civilization. All right. But, take it all with a grain of salt, all right? No matter if what they're saying is correct as far as location, what they're saying about the gene is fact, okay? What they're saying about my genes is fact. Okay? They can't find anything older than my maternal ancestors gene. All right? They can't find anything older than my maternal ancestors gene, and thus I'm classified as descending from the very first woman. So all praise to my Savior, Yahweh Shai, and my Savior's Father in heaven, Yahweh. And salutations to all my brethren, the seed of Israel, the daughters of Eve, the daughters of Sarah and Rebecca, my sisters, the so-called Bantu, all right, the so-called Igbo, all right, so-called Afro-American, all the classifications and names that we have. You know who you are, the daughters of Zion. Salutations to you. Bless you, Jerusalem. Salute. Shalom.